In this video, I will talk about division of common bases with exponent. And I'm going to start with this example of x power 3 divided by a single x. And x power 3 means x times x times x. And top to bottom like this means divide. A numerator over a denominator, the two are being divided. So this x on the bottom can cut with any one of the x's on top. For example, this x on the bottom, because it's being divided, can cut with one of the x's being multiplied, maybe the last one, and you get x times x. And on the bottom you get a 1. And this simplifies to x power 2. Now, I can also perform the same operations by using subtraction. So on the top I have 3 divided by I have a 1, so I can subtract. Because when I cancel or cut or eliminate, I am taking things away. So I'm going to say x power 3 minus 1 simplifies to x power 2. And it's the same answer. It's the same result, top and bottom. Just a different way to think about it. Now, in example 2, I'm starting with more x's on the bottom. More x's are being divided than are on top. So I still will cut an x. An x from the top will cut an x from the bottom, leaving 2 x's on the bottom, or in simpler 1 over x power 2. But I'm going to apply the same idea of subtraction, and I'm going to see what the result is. So I have x power 1 over x power 3. I'm going to subtract my powers because it's division. I can simplify how many are being canceled by subtraction, and that results in x to the minus 2. And these answers are equivalent. I'll explain that one more time here. By looking at the bottom first and subtracting the 1 from the top, and I have this all resulting in a couple different versions of the same answer. And they are both true because x to the negative 2 is equal to 1 over x power 2. Whenever you have a negative exponent, you can move it to the top or the bottom. So in this next example, I have more bases being multiplied and divided. I'm going to start with these numbers, and I'm going to write the 6 as 2 power times 3. 2 multiplied 3 is 6. Because this 2 being multiplied will cut with this 2 being divided. And I'm going to subtract 5 and 3 for the x, because those x's have powers of 5 and 3. And I'm going to subtract 1 minus a 4, minus 1 minus a 4, because these powers are being divided. The base is being divided. And this will simplify. The 2 will simplify away. 5 minus 3 is x power 2. Minus 1 minus 4 simplifies to minus 5. And applying the idea that you can move a negative from top to bottom, I'm going to take this negative exponent, I'm going to rewrite it like that. Now on this fourth example here, I'm going to talk about moving the exponents first, moving the bases with negative exponents first. I'm going to still look at the numbers by finding something that I could cut. So 12 is 3 times 4, 8 is 2 times 4. I will cut those 4s. And when I look at these x's, they are both positive. So I'm just going to leave them there for a minute. But this minus 3, this y to the minus 3, because I can move a negative exponent, I'm going to take the negative from the bottom and move it to the top. I will illustrate that with these z's, which are both negative. I'm going to move the minus 6 from the top to the bottom, and I'm going to move the minus 4 from the bottom to the top. In this problem, I am only moving bases with negative exponents. Notice how this x I didn't move, nor this x over here. Only the bases with negative exponents. Now, after I move them, I ask myself, are they both on top? Are they both on bottom? Or is one on top and one on bottom? For example, the 4 is on top and the 4 is on bottom. So that will simplify away. The x on bottom is more than the x on top. So I will subtract 5 minus 2. I will find out what the result is when these two x's cut out of this. 5 minus 2 will result in a 3. Now these y's are both on top, so I'm going to add those because they're both on top. They're not top to bottom. And these z's are top to bottom, so I will use subtraction. I will cut away. There are more on bottom, so I will make a choice to subtract from the bottom. And this is my final result. You can practice this problem on mathcart.com in the Refresh Your Math section, problem 2.